The next toolbox to look at is the Create Solids toolbox, which contains 5 tools that derive 3D shapes from existing geometry. This is extremely useful because it's often easier to edit existing geometry than it is to create new geometry. So let's open the toolbox first. That's this one. And I'm going to float this as a toolbox again. Pop it to the side there. And we'll take a look at each tool in turn. First one is Create Solid by Extrusion. And you've seen this already. You used this briefly in a previous video. Keep in mind that the tool creates 3D complex elements by extruding a boundary element or profile. First constraint is orthogonal, which you're well aware of, and normally that's on. You can extrude a specific distance, or simply drag and use AccuDraw to set the actual distance. We can extrude in both directions. I'm turning this off for the moment, meaning that it will extrude in essentially what you might call the left or the right direction on either side of the profile that you select. We can set an X and a Y scale for the extrusion as well, and this is the projection of the extrusion, and we'll look at this closely a little later. We can add a spin angle to the projection of the extrusion. Again, we'll look at that. We can set Use Active Attributes to On, which will create a solid with the attributes of the current active attributes. With this off, then the attributes will be retained as the attributes of the profile that we're using. And we can keep or not keep the original profile. You might want to use this again for other operations. Now, the profile being extruded can be almost any type of element, from line strings to shapes and even B-spline curves. You can even extrude text. And this wide range of element types leads to a very sophisticated drawing procedure. Now, before we start experimenting, there are some points you should think about. Firstly, you use a profile or a boundary as the element to be extruded. Technically, a profile is an open element, whereas a boundary is a closed element. MicroStation uses the term profile for open or closed elements, and I'll be doing the same thing throughout these videos. Secondly, while you can extrude a set of separate but connected elements, it's still best to use joined or closed elements, as in line strings, complex shapes, etc., etc. If you do try to extrude a set of separate elements, you'll likely see a warning message advising that your action may result in overlapping geometry. This is not permitted, and the extrusion will not be completed. Thirdly, after extruding a profile, you may not want to see or even keep the original profile element. There are several ways of achieving this. You can turn that option off in the Tool Settings window, as we just saw, or you can draw the profile on a different level from the extrusion, or use a construction class element as the profile. Now, this point becomes significant if you keep the profile, because the profile element is not incorporated into the extrusion and remains entirely separate from the extrusion itself. This may not be an advantage, especially when developing hollow surface extrusions. And fourthly, if you have Use Active Attributes off in the Tool Settings window, then the attributes of the extruded element are derived from the profile element. However, the level can be set differently from the profile element. Now, let's get started with some drawings. You're going to need to switch between a wireframe view and a shaded view, and I assume that you've already set 2 function keys for this purpose. Let's start by looking at a simple angle. So make the settings that I have in here, except that I don't want to keep the original at this point. So only orthogonal is on. And we're going to draw with SmartLine. So start, I'm in the top compass orientation, and no dimensions here for the moment. So I'm going to draw myself an L shape. Again, doesn't matter what dimensions I use. Hit enter and find that point and snap back. So now we have a planar surface. Now I can start the tool and simply select the profile and drag. And you see I'm dragging my solid L-shaped element. And let's just double check that with a shading. There we go. Now let's repeat that process completely. There's my original profile. Let's keep original on. And let's use the active attributes and let's change them to, say, red. Now I'll do my extrusion and data point and drag. And now I see a red element because my active attributes are red. And if I move my element, I will see my original profile in place. So again, that original profile is not incorporated into the extrusion. It's still a separate entity. Spend a little time practicing here with different profile shapes just to see how it works exactly. Then in the next video, we'll take a look at a more extensive exercise.